Okay, guys, this is quite frustrating. I mean, we keep on having some technical problems for the lecture capture. Um, but no problem. I have this program. We can do this desktop recording. I'll give you necessary information. So let's start it. Um, Mostly today we covered about the chapter one lecture, the backup I posted already. But we do mention some new information. Before we get into the lecture, I want to get to know you guys a little bit more. So you can pause the video and answer these 5 questions submitted online on the assignment I created for you already about future goal. And I'll give you points. All right. So now let's keep moving. Now, we'll talk about science. What is science? In psychology, believe it or not, is science. I'm going to show you a clip uh, by John Oliver, if you know about him. If you don't know, I would strongly recommend you to find his clips because he is a comedian, but more so he's a journalist. So he used a lot of humor to take on some really serious problems, and I really enjoy his program. Um, and he talked about science. I'm going to show you what he's talking about, which is quite correct, surprisingly. Um, but before that, I want to explain a concept called significant finding. So maybe you've heard about this before, but let me further explain what it is. What does it mean, significant finding? That means the result of a research is less likely due to chance. All right. Um, so, for example, suppose we do a study about fish eating. Yeah, because people say if you eat fish, you're more likely to be smarter, right? Hey, let's test this hypothesis. So usually, the basic research design is that we have a bunch of people, right? You divide into two groups. One is experimental group, one is control. So experimental group eat fish, let's say, I don't know, for a year, right? And control group, they can eat whatever they want, just not fish, for a year. After a year, we collect data by measuring their IQ scores and compare, right? Now, suppose the average of experimental group is 130. IQ 130 is really high. And suppose that for control group, the IQ average is 70, right? Now, look at this a big difference. Is it possible by chance experimental group people they already are really smart, right? It's possible, but not very likely. Is it possible fish from the result fish actually doesn't work? It's just coincidence. It's possible, but not very likely, right? If that's the case, we'll suspect the assumption that the fish doesn't work, or I mean, these two samples are actually from the same population. This assumption probably is false. The likelihood that this assumption being true is very low. In other words, something we call p-value is very small. If it is small up to a point like less than 0.05, in other words, 5%. If less than 0.05, then we'll say we want to reject the assumption that the fish doesn't work, or reject the assumption that these two samples are actually from the same population. Okay, so researchers will be really happy if they do the research and they find their research result show small p-values. That's all we care about. Okay. On the other hand, though, there are more than one way to get a significant finding. Small p-values, and you have to understand that for researchers, especially most of the people they are in the big research universities, being professors. Like me, I mean, I'm in this, WMU is not a research institute, so I don't have that pressure to publish my research finding. I still do research, but no pressure for published work. But for those who do have the pressure, um, uh, they need to get research results with a small p values, and that's a big pressure. So they will do whatever they can to make the p value small. There are more than one way. So let me show you. The first way, of course, is the treatment or the drug, or whatever is working. Whatever they manipulate is working, and that's great. But that doesn't happen every time, right? So there are other ways we can do to make it small. The second one is you collect a lot of people, big sample size. The bigger the sample size, then the smaller the p-value. You don't have to understand why, but just remember that, at least for now. Um, the third is you study a lot of variables. Because if you have a lot of variables, then by chance something might come out significant. Okay, and the last two ways, big sample size and a lot of variables, is kind of like cheating, you know. And the clip I'm going to show you is called p-hacking. Okay, so I want you to understand this concept. All right, so I will post this clip um, uh, just online. You can just look at it. All right. Now, pretty much today's lecture, we just go through this. Pretty much it's covered in the backup video, but we do mention something extra. So again, we say science, psychology is a science, and science has these three special features. Let's revisit this is systematic empiricism a little bit. We say it's learning about the world through careful observation. But what does it mean, careful observation? Um, to simplify the issue, we turn everything into numbers. Yeah, numbers can be more likely to be objective and logical. Okay, now there comes a question. So if we study psychology, how do we measure, let's say, love? Right? Love is kind of abstract, and how do you measure something that is so abstract? Now, the first thing we do is we need to define what kind of love we're talking about. So, for example, are you talking about parental love, or romantic love, or your love toward some certain people, right? So first we define it. So, for example, I want to do a survey of examine parents' love toward their children. Then I will create a questionnaire, right? Now, how to, okay, so now we have defined what kind of love we want to observe. But then how do we turn it into numbers? One way to do that is um, we use a Likert type scale. So we have questions like, okay, from 1 to 7, 1 being I hate my kids, right? And 7 means I love my kids. So how much do you love your kids? Yeah. And you might need more than one questions, right? Maybe 5 to 10 questions to cover all different aspects, right? Like, do you cook for your kids? Do you clean up for your kids? Do you teach your kids to play with your kids? Whatever, those related questions. Right? So that's one way to turn the one variable, the variable we want to study, into numbers. Now, how about this is a self-report, but how about we study some people who cannot do self-report, for example, children. So, for example, we want to study aggression among children, like a 3-year-old or 4-year-old. You cannot give them survey. They are going to just mess up the paper piece of paper you give them. So you need to find some other way, right? So first, when we define aggression, probably say, okay, what kind of behavior constitute aggression? Like a pushing, staring, verbal abuse, whatever. calling names, and then you need to observe those little children in the natural environment, like with their classmates, if they're in preschool, or their playmates in the park, whatever. And who will do the observation? If you are the researcher, you are more likely to be biased, right? I told the class about this story, fascinating story. Maybe you heard about that before. It's about a horse. His name is Hans, and the Hans can count. Obviously, horse cannot count, but the owner, every time the owner bring the horse to an audience and ask the Hans, announce loudly, say, "Well, Hans, what is a 3 plus 4?" The the horse will stamp 7 times. And that is amazing. And scientists, they scratch their head and say, I mean, what's going on? And finally, scientists tested their theory by asking the owner, say, okay, this time you don't announce it to everyone. You just whisper the question next to the horse's ear. So that's what the owner did. And guess what happened? The horse just keep on stumping, stumping, never stop. So what turned out was the horse, though don't understand humans' language, is so smart to pick up those nonverbal cues from the audience. So when the owner announced, say, what is a 3 plus 4? And he started stumping. When he stumped to 7 times, there's a very tiny body language among the audience because it's his answer. So they're waiting for it. They're anticipating something to happen. And the horse is so smart to pick up the cue, and he stopped the stumping. Yeah. Um, that is a demonstration of how like researchers can potentially contaminate the research by his own nonverbal language or just by his observation. Yeah. In other words, to be scientific, we need to utilize a lot of different methods, approaches to make sure we are objective and logical. Okay. Uh, the rest of the two questions and all the literature are the same. We cover up to about this point. Okay, so hopefully next week everything will back on track. Everything will work. Let's hope.